Okay, so you have been basically working with inequalities and solving them a little bit. So this is just to more formally go through it. And we just have some examples here. The same rules and properties apply to solving inequalities as they do for equations. I can solve them by subtracting the same quantities from both sides, from adding both quantities to the same side, dividing both sides by the same quantity, and multiplying both sides by the same quantity. Okay, so we'll just go through that just to clarify this. So we have y plus 10 is less than 3. So I'm going to subtract 10 from both sides. And that's going to leave me with y is less than, in this case, negative 7. Here I have x plus 7 is greater than or equal to 10. So I'm going to subtract 7 from both sides. And I have x plus 7 minus 7 is 0. So x is greater than or equal to 3. 10 minus 7 is 3. Here I have h minus 1/2 is less than 5. So I'm going to add 1 1/2 to both sides. So I have h, and the two 1 1/2 go to 0. So h is less than 6 1/2. Okay, simple enough. Here I have a couple multiplications, one division. So we have 7 times c is less than or equal to 40. So I'm going to divide both sides by 7. And that just leaves me with c. 7 divided by 7 is 1. So c is less than or equal to 40 over 7. Or, if I'm going to put that in a proper fraction, 5 and 5/7, so mixed number, I mean. Okay. Here we have 4 times g is less than or equal to 25. So again, I can divide both sides by 4 since I'm multiplying the g by 4. Okay, so I'll divide them. So 4 divided by 4 is 1, leaves me with just g. And g is less than or equal to then 25 divided by 4. And you can convert that however you want into either a fraction, mixed number, or a decimal. That would be 6.25 if we did a decimal. All right, then we have t divided by 2. Remember, that's fraction bar is also division sign, is greater than 10. So since that's division, I want to multiply both sides by 2. Okay, so let me just write this out a little bit. I have t divided by 2 times 2 is greater than 10 times 2. The 2's go to 1, right? 2 divided by 2. And so I'm left with t is greater than 20, which makes sense. If I take, in the original, if I take t and make it 20, 20 divided by 2 is 10. I'm saying, so t has to be bigger than 20, right? And that's exactly what this is saying. Then we have negatives. Okay, and negatives are the only way this is different than normal equations. If I multiply or I divide by a negative, I must change my sign. Okay, and let's go through this. So here we have negative 9 times x is less than negative 27. So since I'm multiplying, I'm going to divide by negative 9. So now I'm left with, well, negative 9 divided by negative 9 is just x. And, oops, negative 9. And negative 27 divided by 9 is a positive 3. But because I'm dividing by negative, I have to change my sign. So x is greater than 3. Here we have x divided by 5 is 7. So since I'm dividing by 5, I'm going to multiply by negative 5. So negative 5 is x divided by negative 5. So I have to multiply both sides by negative 5. So again, we have negative 5 times x divided by negative 5. Negative 5, non-division sign. And we have 7 times negative 5. Okay, so these negative 5s go to 1. So we're left with x on the left side, and we have negative 35 on the right side. Because I am multiplying by a negative, I need to change the sign. So it's now x is less than or equal to negative 35. One last one. We have negative 7 is greater than or equal to 2 times f. So since that is a multiplication, I'm going to have to divide by 2. Okay. And again, the 2's go 2 divided by 2 is 1, so that leaves me with just f on the right side. I have negative 7 divided by 2, which is negative 3.5. And my sign originally was greater than or equal to, so it has to change to less than or equal to. Okay, so that should set us up and we can do problems in class, and I'll see you then.